In this video, I'd like to talk about one of the basic surface finishing options in SURFCAM, namely 3-axis cut. To begin, we move up to NC, down to 3-axis, and down to cut. Click on Cut, and SURFCAM asks us to select a surface to machine. This is very important, as 3-axis cut will only machine a single surface at a time. I click on the surface I want to machine, and our tool information appears. I'm going to change our tool from a flat end mill to a ball nose end mill, choosing a 375 4-flute ball nose. Click OK, then I'll just change the tool number to something appropriate. Our next step is to go up to cut control. The first thing we see in cut control is a stock to leave amount. This is the amount of material left on the surface after we've completed our 3-axis cutting pass. If we leave it at 0, we're going to cut to the surface. If we leave a positive number of stock here, we're going to have extra material on the surface. If we put a negative number in here, we're going to remove extra material from the surface. I want to cut to the final size, so I'm going to leave the stock amount at 0. We have different ways of containing the tool, that is, restricting tool motion to a particular region on the surface. We all have patch, spline, and both, but I'm not going to use any of those right here. Two different ways of getting from one pass to another: an increment, which is a fixed distance between passes, or a scallop, which is the ridge height between two consecutive passes. I'm going to leave it at increment and step over at 100,000 step size. Our surface tolerance is a very important number. All moves on a curved surface are created by a series of straight lines. The surface tolerance of 1/1000 in this case is the maximum deviation from the true surface that you're allowed to have when cutting. In order to achieve a better surface finish, you can reduce the surface tolerance down into the tenths range, but this will give you a longer part program. Our retrace type is concerned with how the tool moves from one pass to another. When we have it set at bidirectional, the tool will cut back and forth across the part. If we want to cut in one direction, we can choose either top plane or relative plane, and the tool will move in one direction only when cutting. For now, I'm going to leave it at bidirectional. Our rapid plane is calculated to be above the highest point of the part, and our plunge clearance is the standard 100,000ths. I'm going to click OK and see what kind of tool path we get. When I accept this, you can see the tool plunges down where the arrow is. This is critical because all tool motion on a 3-axis cut is controlled by the surface arrow. The tool will start cutting where the arrow is and cut in the direction that the arrow is pointing. If we look at our backplot operation for 3-axis cut, we can see this very clearly. Plunging down at the arrow, moving to one end of the part, and then cutting back and forth across the part. I'm going to stop this right now and make an adjustment to the surface arrow. We'll get out of backplot, and then we'll move up to Edit, down to Surfaces, and here we see Side, Direction, and Corner. I'm going to change the direction of the arrow simply by clicking on the Direction button, clicking on the surface, and now the arrow is pointing over the top of the part. I can change the corner by clicking on the word Corner and moving over to a different corner. Now if we go back and look at our tool path, you can see that the 3-axis cut tool path is no longer associated with the geometry. To fix this, I'm going to right mouse click and just left mouse click on Regenerate Toolpath and reselect Geometry. We'll accept the same parameters and I'll click OK. Click on the surface, and now we cut over the part. Going back to backplot, click OK, and we'll start. Here we start where the arrow is and cut in the direction that the arrow is pointing. One thing that's important to realize, which you can see if we look at a front view of the part, is that the tool tip is cutting below the bottom edge of the surface. This is because the tangency point between the tool and the surface are at the 0 or 180 degree mark. If I want to change this or fix this, I can go back to the Operations Manager, right mouse click on the toolpath, regenerate with original geometry, go to Cut Control, and right down here I have a minimum Z value. If I tell it the minimum Z is 0 and click OK, our toolpath is recalculated. If we look at the back plot for this operation, we should be able to see the tool tip stopping at the Z level of 0. Change to an end view, and this will become even more clear.